Ladies and gentlemen, welcome back to another live stream. Okay, let's see what we got today. So today we're going to be continuing, this is like the second part of our series. Very much of creating a game engine using SDL GPU by kind of vibe coding it to some degree. But yeah. Okay, so the mic is good, great. Pop out the chat. And let's go. Okay. So I did a few changes off camera, pretty much, nothing fancy. And this is what we got so far in terms of results. So just got these kind of instances of geometry with different materials. So I created two materials, so like a wireframe material, and I also added texture in, if you noticed. And yeah, I think let me show you a bit of the what's going on here. Okay. I'm not sure where we left off at the last stream, so I could show you what I've done. Let's see. Refactor GLM. I think I've done this one in stream. And this one in stream, probably. Wait, scene owns geometry. Let me see this one. What it does. Make unique. I think we left off probably from here. Yeah, I think I've ended the stream probably here. But yeah, so I've done nothing really fancy, to be honest. So I just moved the geometry data from, I think it was in the renderer, and I moved it to the scene, essentially. And then we got multiple meshes with transforms, and the renderer iterates. Let's see. Yeah. Anyways, next up, we also got refactoring split mesh into geometry plus instance. So what was happening is that it was trying to like clone the whole geometry every single time it wanted a new instance. So what I've done, I made it like just create the geometry once and then share that geometry between multiple instances that use the same geometry. Nothing fancy here either. I think next up we got feed multiple geometries with per instance geometry index. Yeah, same thing, I think. But obviously you could find all of this in the what is it called? Yeah, the GitHub repo. But anyways, let's see what we got. Where's the chat? There you go. Okay, and then what we got next? Yeah, I think the live stream I've ended it here pretty much when I created maybe the license. Yeah, I guess so. So first of all, I actually fixed the double free. So we had a little double free because the base path is not supposed to be freed, and the AI was actually freeing it in the destructure, which sucked. And now it no longer crashes when you exit the program. Other than that, we got some ownership semantics. Yeah, I just made sure that it made the correct move and copy constructors in every class. Then I added texture support, and I made sure that the CPM folder, which is just contains the loads, it would be get ignored properly. And I compiled a few shaders for the texture and so on. I just got the texture from SDL through GPU examples, nothing fancy, just for testing. Next up, I created the material class essentially, which would basically encapsulate the pipeline creation setup. And yeah, nothing fancy there. Next up, I added the wireframe material to test multi-material rendering. So I just added the little, yeah, basically another material. If you see, I guess, in the scenes. So as you can see, this is how you create a new instance in the scene. You just push back a new instance and you choose which geometry you're going to use. And you choose which material you're going to use, material index, and that's all. Nothing crazy there. And here we're obviously like loading the wireframe shader and stuff. Yeah, that's all. Other than that, I also decoupled the scene setup from scene class. Yeah, so basically we had the scene setup basically over hard coded into the actual scene class itself, which is obviously not very useful other than testing. So what I did is right now the actual main function is the one that makes a test scene. So this is how you make a test scene. You create a new scene, then you can add geometry, and then you could use scene create cube, which gives you back some vertices and indices for a cube. Then you give it to add geometry, which creates some geometry and upload it to GPU, etc. And then gives you back an index, which you could use. Same thing with a pyramid. And then you just add instance, and then you select what geometry which you're gonna use, and then obviously the material that you're gonna use, and that's all. Nothing fancy there. So yeah, and here just a little bit of rotations and stuff just for testing. Yeah, pretty much. Next up, we got the move cube gem. Okay, so then I moved the cube and pyramid stuff generation into its own little helper class called geometry instead of stuffing it in the scene just to keep things organized. And then I created a little spiral scene with 40 instances and increased camera range. And next up, I also made sure to skip the redundant material binds in the render loop. Skip the redundant. Hold on a second. Okay, back. Let's continue. And then finally, the last thing that I've done yesterday uh, was resource manager texture loading with CPU, GPU separation and batched uploads. So this is a bit interesting. So it's kind of preparing for asynchronous asset loading, essentially. And so I tried to separate between the CPU side of the texture creation business and the GPU. So hopefully I could like load textures, for example, asynchronously using the new SDL3 async API. And then once it's done, then the GPU would go ahead and upload it, kinda, and then it would just pop out. Honestly, I'm not entirely sure what we're gonna implement in today's live stream. Guess we'll find out. But so far, so good. So far, so good. All right, so I mean, we could try to implement, let's say, asynchronous file loading, or we could try to even maybe instead of using this kind of add geometry stuff, we could use NTT to try it out. And yeah. All right, let's see what's up with the AI here. I just told it to review the code quality and stuff. Associated objects that are created but not tracked. Hold CPU data. Okay, move operation don't handle the case where this is equal other and the move constructor material. The move constructor doesn't check self move. Though in practice this is extremely unlikely with CD move. So global operator new, override. Recursive call. Ooh, I see. Interesting. Interesting. Anyway, so honest assessment, B minus overall, solid foundation, a few real problems. So clean modern C++ 26 style, designated initializers, consistent coding conventions across all files, good error checking pattern with check and SDL exception, thoughtful batch deploy design, correct exception boundaries and SDL callback interfaces, and what needs attention, critical member initialization order UB, 12 in checked SDL calls. I believe probably just like I don't think that's true. And used entity dependency, we haven't used it yet. No RAI wrappers for the GPU resources, raw pointers with manual, that's fine. And yeah. So what do you think should we work on next? Let's get some suggestions. Fix bugs and hardens. Man. I mean, if there's no visible bug, then there's no bug. So build on what works, add new render features, or refactor architecture, or all of the above. Let's just add features for now. Submit. Let's see what it's gonna say. Explore the current rendering capabilities. Add normal to vertex format, fragment push. Should we try some lighting, honestly? Yeah, maybe. Yeah, that would be a cool next thing. No, per pixel lighting and normal to vertex format plus basic lighting, fragment shader, biggest visual jump from current state, then fragment push constants. Add per instance color or material via fragment, let solid color, no, and blend state. So per pixel lighting, let's go. So let's add a little bit of lighting, honestly, fine. I think I'm probably gonna start adding some physics engine, honestly. And for that, we're gonna either use Box 3D, which is like the new physics engine by the same guy who created Box 2D, or we could go with Jolt. And honestly, I have a lot of questions between these two physics engines. That really interests me. So you know what we could do? We could get clone both of those physics engines into our references folder. Then we can ask the AI to really give us an actual real analysis of what's really different between them. Because honestly, I couldn't find any interesting description of what's really different. And obviously, I'm not very experienced with physics engines to understand the code and stuff. At least not most of it, but yeah. How should the light behave? Right. So it's gonna expand the vertex format, add normals to geometry data, transform plus past normal. Okay, cool. And diffuse lighting, accept world normal input, add fragments, push constant block, cool. Compute, all right, saturate dot normalize, world normal and normalize minus light direction. Then the final color, same lighting optional. Interesting, pass it to recompile the shaders and then the render approach, single directional light. What's this? The same single forward render pass, two materials, textured plus wireframe, push constant for MVP, vertex stage, no new dependencies. So we could either do a fixed light, hard-coded light direction color simplest to implement, or light orbits with the camera or scene, more dynamic look. Allow multiple lights for more complex scene. Let's start with a fixed light. Let's start simple, fine. Should the wireframe material also be affected by lighting? I don't think so. The green wireframe also responds to light direction. No, keep it flat green, I think. Wireframe material shouldn't be affected by lighting. hmm Okay, go ahead. Add normal to vertex struct, rename to position normal. It should just name it like vertex, but whichever, anyways. And then you got add per face normals to cube. Okay, and then you got transform plus output world normal. And add like push constant compute and dot L diffuse. Okay, let's go. So we added a normal there. Yeah. Okay, back. Okay, sick. Is the stream fine? No dropped frames. Nice. We're already 20 minutes in. Okay. Alrighty. So what's going on here? Let's see. Read geometry to CPP. Added normals into the geometry that we have for cubes and pyramids and crap. Nice. Yeah, we should also add GLTF. We could also add a sky. Yeah, I was kind of inspired. Right now, I'm starting to get back. The coffee started hitting my brain. Anyways, now the shaders and renderer, let me update them in parallel. Okay, ball MVP. Light block. Nothing fancy there, just regular light calculation. Yeah. I added, I guess, another vertex attribute, obviously, for... Actually, no, I just changed the name, yeah. It did add another attribute, though. For normal, right, yeah. And right now, actually, the render function takes the light color, the light direction, ambient color too. That kind of suck. Yeah, we definitely should maybe use NTT already. Now that we have some lights going on. Yeah. Okay, let's see if it have done the lighting. Hello, Raj Aryan, all 1DZ. Welcome to Livestream. For the last 6 months, I'm just writing Vulkan backend and archive my game engine. 60 plus files crossing backend. Yeah, Vulkan is insane, man. Vulkan is insane. It's just not worth it for most of the time. It's insane for real. SDL3 GPU is such a breeze. Um, okay, what's going on here? Could not create graphics pipeline states. Yeah, cool. So it has an error apparently. So let's make it investigate what's the error. Yeah. Oh, initialization failed. It just says that the parameter is incorrect. Oh, wait a second. Yeah, so that kind of suck actually. So instead of like taking me to the place where the check got called, it takes me to the SDL, to the check function. Which, yeah, we should definitely fix that by basically allowing the SDL exception to take a lock, and then you could just pass it from the check. Yeah. So we could see exactly which call actually did the problem. But we could fix that in a second. Let's just see if the AI would figure out what's the problem it made. But yeah. Found the issue. The fragment shape declares register B1 space 1. SDL3 maps uniform buffer slots sequentially. Start from 0. Since the fragment shader only has one uniform buffer, it should be at register B0 space 1. And we push to slot 0. I mean, read only mode, so here's a diagnosis and fix plan. I mean, go ahead. Hey man, what's good? Sorry about you guys and friends. Axorus, welcome to live stream. I don't really follow football, so you're fine. I'm an alien. While the football stuff was going on, I was actually asleep at that point, dreaming of Vulcan. Good morning, Yo-Yo Man. 3D, welcome to the live stream. Welcome back. Yeah, I started for learning about GPU and driver now. I contribute to Blender and try and mess a great learning project, but I think I just need more 6 years to write Vulkan. I'm really glad that you were able to contribute something to Blender. That's a dream, honestly. I'd love, like, it's such an amazing feeling to contribute to an open source project. And also to contribute to another project, like, sorry, and like to get contributions, I mean, yeah. So kind of communist in some to some degree. It just like feel that, I don't know, that spark of like what is it called, uh you know, collaboration or cooperation, right? Like people that you don't know at all from all across the world, you come together and you just improve something. It's such an amazing feeling. It's like it's very hard to actually get that feeling somewhere else, but nowadays at least. But yeah, open source projects are such a dream. Anyways, they're probably not a dream, honestly, to maintain. Like, if you come to the real world, like, the open source maintainers are probably having such a hard time. Uh, but yeah, it's pretty cool. Anyways, no C++ changes needed. Only shaders were recompiled. The binary is already up to date. Try running it again. Let's see if he was able to fix that. Yeah, it didn't. Interesting. So this is a good start. Well, first of all, I want to fix though is the fact that this is supposed to give me some actual good location. So let's fix this little helper thing really quickly. Actually, we could already do that. Yeah. So you know what I'm gonna do? I'm gonna grab this guy and put it as another parameter in the check functions, right? And then I'm just gonna give it to the SDL exception. So it would give us the right location where the error happened, not the check helper. And yeah. Because right now it's just giving us the line of the helper function, which sucks. And boom, look at that. Nice. And so that happened in obviously in Material CPP. But the problem here is that, wait, hold on. It did tell us actually, GPU vertex input state could not. Yes, so I guess maybe something with that have to do with the vertex input state. The vertex input state. Okay, who's calling this guy? Who's making the material? I think there is a way, wait, there is a way to find the usages. And let's see what we're using it for really quickly here. Wait, where's the usages, bro? Well, I guess probably it's being used maybe in the renderer, I would guess. Yeah, I don't know. Let's see if we could figure it out. I wonder if like Vulkan validation could give us some idea of what's going on wrong. Because yeah, like for example, the nice thing about Vulkan is that it gives you very detailed errors that you know exactly what's the problem straight away. But like abstraction like SDL3 GPU here gives you like a vague error and then you gotta figure it out. Yeah, very hard to contribute, but I ST from Academy before Foundations Academy Software Foundation, the libs Blender used for some VFX work. And after I spent 5-6 months in Blender, then one PR got merged. Yeah, such an amazing like achievement, honestly. Really great achievements. Congrats. The error makes. Actually, we should maybe make some, but they'll probably ban me because I'm using AI, and they're just having such a hard time of people like the AI just hallucinates some. Because honestly, if you pick an AI and you just tell it to find a problem or see if there's a problem, it would find any kind of problem, and if it doesn't, it would make it up. So yeah. Anyways, so the error makes sense now. The build said Ninja. Bro, what the heck? What the hell, bro? The error makes sense now. The build said Ninja know what to do. My god, bro. So instead of running the program and seeing what the error is, it have built and Ninja just said no work to do, meaning it's already built, and then it just said, yeah, the error makes sense now. Insane, bro. Well, the post build command that copies us to the build directory never ran. What? Oh, sorry. I see. So it's seeing another problem. Okay, wait. The executable is still loading the old compiled shaders, which have the old. Really? I don't think that's the case. Manual copy, please, so we could test this theory. Okay, let's try. And boom. Nope. Nope. So we're up for a very good start. We're up for a really good start. I feel like the model just got like nerfed somehow. I don't know. Yeah, I feel like it got nerfed. That's the problem with free models, is that you cannot expect reliability from them. But anyways, let's see. You know what? You know what we could do actually? Hold on. So, we could basically do this, okay? Go here, make a little breakpoint there, and let's see what the heck is going on. Let's get dirty. By the way, did the AI said anything yet? No. Okay, let's see what we got here. So this is the source code of SDL. There's a lot of stuff going on. Oh boy. Hello, default user. Welcome to Livestream. Fable, make me gaming. No, I didn't choose it that way. Cause like I'm pretty sure if I just gave Big Pickle such a prompt, it would do such. We wouldn't even reach a proper cube. I would guess. At least not in a very good time. Maybe if you give it some enough time, possibly it would do something basic. But yeah, won't be able. I don't think. It should be able maybe to do something simple. I don't know. I don't know. But like, last time I tried to do such a prompt, it just got stuck in the first like CMake setup. That's why when I started this project, I just like made the CMake setup myself. But yeah. All right, so SDL app failure. I couldn't like. How do you figure out where the problem is? That's nice about the AI. Could just read through the source code really quickly. But let's see if it's really right or no. Oh, it got fixed now. Nice. But where is the light exactly? Okay. Fable will bankrupt us before even rendering an image. Oh, yeah. You reminded me of something that happened to me like yesterday. So I've opened up Open Router. Um, and then what happened to me is that like I found that I had $0.40 left there from some experiment or whatever. And I tried to run Claude Sonnet in in open code, right? And it just like burned through that in the first prompt. It didn't even give me one answer. Like just running it, just starting it off, it burned through that whole budget and aired it out. Insane, man. There's no way I would pay for like maybe open code Go subscription could be more interesting. I don't know. And also there is a bug here, by the way. Yeah, there seems to be a bug. Yeah, I feel like the free model got nerfed somehow today. Thank God they have GPT 5.6 competing with them now. They're presented to users at the moment 5.6 was released. Yeah, honestly, I wouldn't like if I'd pay, I'd just pay for maybe open code Go subscription or any other monthly subscription, not API keys. Because what the heck? Like, especially if you're gonna go with like, an agent, because it just burns through a lot of tokens really quickly. Still use Gemini Flash for free, and Gemini free sometimes. Yeah, I also use only free models, honestly. Okay, so the real question is, how do I know where is the light? But at least it works now. which is nice. Is AI really good at graphics programming though? It's as good as you prompting it, I guess, and making sure it doesn't do weird stuff. But like, if you don't know what you're doing either, it just suck. Use free model plus abuse free trials. Let's remove this guy and let's run again. Ah, you got to steer the models basically. Yep. It's as like the ship is as good as its captain, essentially. So if you don't know anything about graphics programming, you could probably do something like some prototype or whichever, hopefully, if you're lucky. But then, especially if some error happens or like whichever, you're just stuck pretty much. And even when you know what's going on with graphics programming, if there was like a mistake in the middle of the project and you haven't wrote the project yourself, then you kind of like gotta just reread the whole thing yourself, or at least the commit, which kind of defeats the point. But anyways, so what I'm gonna tell it to like make it clear where the light sits and its range. I mean, render something for that. Did you try High 3? It's free. I've seen High 3, but I feel like Big Pickle is honestly very good. I just don't know what's going on today. It kind of sucked today. But anyways, to show where the light sits and its range, we need to switch from directional light infinite. Oh, it's a directional light. My bad. Actually, point light is way better at. Hmm. Yeah, honestly, add a direction, a point light, please. It's way better. Wireframes for sure. So I could just have an idea of what I'm looking at least. So yeah. But yeah, so far the lighting implementation doesn't look there's great. There's a lot of weird stuff going on. And honestly, I'm trying to think of a way which I could allow the agent to debug the graphics itself. That would be cool. So let's see. Good choice. So it's gonna add a sphere geometry generator to our geometry HPP. Sure. Implement UV sphere generation. All right. Convert directional light to a point light, and then fragment shader computes distance-based attenuation. Oh crap, no. Ah, I see. Just pass the matrices separate instead of the whole MVP. So the vertex shader computes the world pause and pass shader fragment, update the range push point light data. Anyways, just go ahead. How does High 3 compare to Big Pickle and the other free models here? I honestly haven't tried the other models too much. Last time, yesterday, I tried Nematron a bit. Wasn't really a big fan. Honestly, I had the best performance with Big Pickle. Oh yeah. All right, let's see what we got here. So geometry CPP. The AI is pretty good, like at generating stuff like this. Just creating sphere geometry and such boilerplate. It's pretty good at this kind of tasks. Yeah, the render function just got a lot of freaking parameters right now. I think maybe NTT could help with that part. Okay, so instance transform and view projection, sick. So right now it's gonna pass them separate, which is great. But either way, at least I would say the AI is very good at like prototyping, just get a feel of what's possible. And just get a rough idea of how you would implement it, and then honestly you would just have to rewrite the whole project yourself to make sure you understand every bit that is involved in the process, because otherwise you would definitely at some point you would just reach a roadblock and you wouldn't have no clue how to go about it. So yeah, I wouldn't honestly use like AI for production, like if I was betting my life on it, kinda. And the light is just too big, bro. And honestly, that doesn't really look, I don't know. That's weird lights. You know what I'm gonna do, honestly? I'm just gonna like roll back everything here because it just did such a bad job with the lighting part. Right, so I'm just gonna roll back everything and we're gonna try something else then. Yeah, we're gonna try something else because it did such a bad job there. And yeah. Right, let me try, I guess, to recompile maybe. So shaders asset slash shader slash compile PS1. Whoops. Really? Let's remove the build and try again, I guess, fine. Yeah, let's try something else. Maybe let's try GLTF loading. That would be interesting, maybe. And fail to open shader. Yeah, it's not running the shader compiler itself. Okay. What? What the heck? MSVC debug assets? Really? Where's the load shader part? Hold on. Let's go to our resource manager. I mean, it was working just fine. What the heck? How about I do this? There you go. That's weird. Use new fast GLTF. It's very good. Okay, we'll see. Now, you know what? I'm just gonna remove this session and then just start over. Fine. And let's just push this fix. I don't know how it was working before without any problem. I don't know. It's strange. But commit and push. Anyways, so read the project. Let's try. Or maybe we could try to tell it to try to use NTT. Yeah, let's actually see. Let's see about that, honestly. Okay, research. First of all, I'm gonna tell it to research first. Research about NTT. Uh, or like, does NTT have tests? Hold on, let me see, because I've never actually gone through that one. There is some tests. Is there some examples by any chance? Not really. There's only tests apparently. There's even test beds and so on. But yeah, read through NTT tests. So we could have an idea of how it works before we tell it to implement it, because otherwise it's just gonna not do a great job. Oh, that's a lot of tests. Pointers table. Now that you have an idea, we could tell it to go ahead and like implement it. Okay, now implement NTT into the project. Let's see what it's gonna do. What do you think? Because like there's levels basically to the integration. We also want to fix the member in it or bug in engine. Yes, fix it, fine, who cares? The render code is a toy scene with manual arrays. Migrating fully to entity shows off the library properly and makes the code idiomatic. The render already does material batching using entity view with a sort on material index. Makes this cleaner and opens the door for proper ECS patterns later. Nice. Move the uploader before resources in member declaration, and then define the ECS component type. So it's going to define a geometry ref, a material ref, and a transform, and replace class scene with an entity-based system. Okay, so I guess maybe the scene class, the whole scene class would just fade away. That's interesting. Use entity or just store entities, new API, create entity. Okay. Implement using registry create, registry in place. Refactor render for entity views. Render takes entity registry instead of scene. Nice. And then keep geometry buffers, still iterates to create GP buffers from scene geometries. And then you got the render method. Replace for every instance with view.sort. Okay, so we would use it to sort the materials for batching, by material for batching. That's cool, actually. Lovely thing about entities that you could do something like this very easily. Sick. And then you would grab that, and then you would bind material if changed. Okay, becomes populate scene, creates entities, and place components, iterate. Yeah, sure, I guess, fine. Go ahead. Let's see what it's gonna do. Maybe I should have told it honestly to first of all research the APIs it's gonna use, but well, whatever. Let's just see what it's gonna do here. So it creates the components HPP, which contains a transform, geometry ref, and material ref. And it creates the scene HP. Well, wait. Oh, okay. So it returns a entity instead of the instance thing. Cool. Nice. That's pretty cool. You know what would also be cool? Maybe trying some GPU based rendering. That also would be like using compute and like indirect commands and so on. Would be cool to experiment with those while we're here. Hopefully would figure out quickly to just use the VCS ball thing. There you go. Actually, yeah. Yeah, it keeps on like fine. Allow always. There you go. Cool. So I think right now it's probably building. Yep, it is. Okay, it seems way better now. But let's see if it worked. And yeah, it seems to be still working just fine. Lovely. All right. So this is the main function now. It's using NTT, so just grabbing the view geometry ref and transform apparently. And for every entity gets the entity, what view get entity and georef and X form. All right. And the renderer takes in that. Wait, where's the renderer? Hold on. And so now the renderer, what it does, it's yeah, so it just says scene.view, and then it grabs the geometry ref, the material ref, and the transform, and it sorts the material. Wait, where's the sorting of the materials part? Oh, what? It did talk about sorting the material. Did it give up on that part or what? That's strange. Weird. Or did they add it somewhere else? Huh. I don't know. But that works. Anyways, that works. All right, so what are we going to do next? What are we going to do next? Let's ask if there's anything else you can use entity for. I wonder if like you could use it for like, classes and stuff. I don't know. Like the other stuff we have. Ooh. Use on construction update on this structure automatically queue GPU uploads when transform geometry or material changes. Sick. But wait, that would make so that whenever I guess you change a transform, you would have to re-upload every single time. I don't know. Yeah, that's pretty interesting. But I think we'll just move on to the next thing. Research GLTF libraries that exist for C++ in 2026. I mean, obviously there is async, but async is huge. It contains multiple formats, which honestly, it's a waste. Feel like GLTF is enough, more than enough. And yeah, fast GLTF is this. This is the one that, yeah. So it's SIMD accelerate 24x faster than tiny GLTF on base 64 embedded buffers. That's sick. Okay, integrate fast GLTF. Hello, Subedara, no, and welcome to Livestream. Yeah, I am making a game engine. Right. Alright, GB index size, right. Like the vid sprite is a must. Thank you, Subedara. Thank you so much. Okay, let's see what's up. No updates. Main CPP. Yeah, we should look for some meshes, but I just want to keep an eye on it. I wonder what it's doing here. Having some problem, I guess, with fast GLTF. Ah, I see what happened there. The GitHub like failed to check out because when you use this thing, you have to use basically just the version directly instead of V. So yeah. The live stream have gone for a little while for whichever reason. Anyways, reconnected. And I think right now it's building it, which is nice. Lovely. So apparently, I guess FastGLTF had some sort of an upgrade from a new to a new API, and it basically I've gone to like understand it, and then I would guess right now it keeps on tripping up with the like the MSVC compiler. It can't find it. Like you have to actually call this bat file to get the environment. Yeah, it keeps wasting a lot of crappy time on that. My God. Okay, right now it's doing the job. Cool. Did it actually change the model loader yet? I mean, it wanted to refactor it. Oh, there you go, I guess. What the heck is it doing now? I don't understand how it keeps tripping up on MSVC. Use GPT 5.6, it's very good. Is it like a free model? And welcome back to the live stream, Sanatani. I don't think it's a free model. And yeah. You can try with $20 plan. Ooh, $20 plan. Yeah, I'm thinking of buying some. Wait, I'm thinking of buying some model. I'm not just sure who. I need something that is good as a subscription. And honestly, I'm thinking of using like buying open code Go plan. But yeah. All right, so what's up? I think it's done, I guess. Build passes, link successfully. Let's see if it works. I mean, I do see something here. What the heck? Bro, what? What? Let me grab render doc. And how are we gonna do this? Let's see. So just gonna grab the, yeah, open code Go is good given it's cheap and favor open source model. Yeah. All right. So where's the compiled executable here? Build. And there you go. Now just copy the, where is it? Copy path. Absolute. Let's come to launch the application here. Executable path, launch. Let's capture the screen here. And let's see what's going on here. Ooh, okay. Okay, so that mask. All right, cool. So I guess it's been loaded correctly. It's just that maybe it's too tiny or something. I guess that's what's going on there. You know what I could do? I could export to CSV and just call it something, I don't know. Then I could give it here. Session compacted. Is it maybe like too big? Well, a bit. Maybe we should have tested with a smaller model, huh? But yeah. Okay. Oh boy. Yeah, I should have not done that. Yeah, it couldn't like fit that whole thing into its context window. But yeah, I guess like the GLTF loading though seems to be working just fine. Yeah, right now it's just like a problem with the way like how big it is kinda. So let's see. Yeah, conversation history too large to compact. Exceeds. Yeah, I should remove this. Yeah. Let's see if that would work. Yeah, I thought it was kind of clever, like putting the whole VS output file into there, but there you go. Oh boy. I think I probably broke it. Oh crap. All right, fine. Let's just delete the whole session and let's start over. Read the project. Yeah, that was a mistake. Like putting the whole vertex output file into there. I'm not sure what I'm seeing here, to be honest. Hmm. So like, I guess maybe I'm seeing like the inner geometry out there, or what? Yeah, the shading looks off.